and see what some of our first calculations are. It's first going to start with running right through the heart of chemistry. So we have a chunk of sodium metal. Sadly, we are not allowed to buy that. If you're careful with it, it's not so dangerous and violent, but that's not something our school really likes to have us purchase. And we have 50.4 grams of sodium used, and it asks us how many moles. So if you like to go ahead and write that out, we have 50.4 grams is equal to question mark moles. Now, sometimes you don't have time for that on an AP test, so you want to at least circle the key important factors. And mass to moles use molar mass. And we're going to use our molar mass from our periodic table here. Now, when you do this, I just ask that you use 2 decimal places for the molar mass. That's usually sufficient to achieve the number of sig figs and the accuracy in our value that we need. It's a good idea to label, because if we switch substances, you don't want to be missing out on a step. Now, we want to eliminate grams, so we're going to put grams in the denominator. We want moles. And for every 1 mole of sodium, we have a mass of 22.99 grams from the periodic table. So double check that your units cancel and you have them set up. And if you are forgetting a little bit about dimensional analysis, you can look online at Vimeo or YouTube. And if you look at the latest pre-AP videos, pre-AP videos, there's quite a few on dimensional analysis, and you can get a nice review of the technique of dimensional analysis. Now, if I perform that mathematics, I get 2.19 moles of sodium. So that's an introduction to this. Now, you certainly could have done this in a formula fashion as we did last unit. Last unit, I was trying to focus on using formulas, so molar mass would have been mass over moles, and you know the molar mass, you know the mass, you could have solved for moles. But right now in this section, I'm trying to move us towards implementing that as a conversion factor. Now let's take a look at this next one. We've got 0.250 grams of Ritalin, commonly used to treat ADD, and there's the chemical formula. Now, if we want to go from moles to mass, we need the molar mass of this substance. And just as a quick refresher, I have 14 carbons. I'm going to take our molar masses to 2 decimal places. I have 19 hydrogens times 1.01. Please don't round here. We're going to come to some problems where if you round too much, it can really throw off your process and make it much more complicated than it needs to be. So if we add all those up from the periodic table, we will get our molar mass for our Ritalin, and we'll have 0.250 grams times, now I'm going to set it up the other way for those of you who like that a little bit better. This way shows the mathematics a little bit. And we want to get rid of grams. We want moles. For every 1 mole, that if we added all that up above, we'd have 233.34 grams. Again, make sure your units cancel. They're in the numerator and the denominator, and when units are opposing like that, they'll cancel, and we get 1.07 to 3 sig figs times 10 to the minus 3 moles of Ritalin. So hopefully that's giving you a brief introduction to mass to moles. We'll keep repeating this concept throughout the chapter, and so we'll definitely get much more practice on that. And in the next unit, we will do a refresher on using Avogadro's number in our calculations.